In the last video, we talked about using the Pandas.merge function, this merge function, to combine two data to one data. So this is a function, and we apply this function on two data frame. So it's here pd.merge, left and right. Left is a data frame, and the right is another data frame. So we apply pd.merge on these two data frames. The data frame itself has a method called merge. So you can directly use this merge function, this method on this data frame. It's a little bit different than the pd.merge. pd.merge is a function, while pd.dataframe.merge is a method of a data frame. And this is documentation. If you Google dataframe.merge, you will find it. Let's look at some examples. For example, this is data frame, and it's and this is this is color, and this is a data frame. It has a column called key and another column called A. For example, key is your name or a national ID number, and A is some of your information, your address, for example. And this is another data frame called other. Now we want to combine them together. Well, we can certainly use pd.merge. But we can also use this data frame caller method merge. So caller dot merge, it says that you want to merge another data frame called other to this caller data frame, and you want to merge these two data by the column or variable name key to the left, which is a key on the caller, and the right data frame's key also key. Well, since the two variables have the same name key, you actually can use on equals key, not these two. I just want to explain why it's what they mean. And how is inner? That means only the observations or the rows that exist in both data frames will enter into the combined data. So for example, this is key 0, key 1, key 2, and here it has K0, K1, K2. But the other doesn't have K3, K4, K5. Therefore, they are not in the combined data. Okay. The caller itself doesn't change. What changes is caller merge. If you want to save it, you should combine, like maybe just caller 2. Okay. Then caller is still the same, and caller 2 has 3 rows. Similar to pd.merge, we have a parameter called how, and how can be left or right, outer. Maybe I should left or right, outer, and inner. Okay, the default value is inner. Say if you want to use, if you want to merge other into the caller and on key, because both variables in both data frames are key, the names are key, and how is outer, then sort equals 1, assign 1 value, is that it sorts the join keys lexicographically in the result data frame. Okay. So, well, You don't have to have the sort now, I think. So the inner part, if you merge the two data frames by inner, then this part is retained. And you also have the colors 3 observations without that are not matched with the other. So you have an NaN for B, for the column B. If you use right, you will have the, I think it's the same as inner, because the observations of keys, the observations of keys for other is a subset of color. So this is very simple. It's just the data frame merge. Next, we go to merge as of. Merge as of is kind of like a fuzzy match, but it's not really. We will talk about fuzzy match for the strings. Here, the merge as of will merge 2 data frames based on some values, some keys that are not exactly the same, but it's only applied to the date time. The datetime values of data. Think about this data frame traits. Uh-oh. Uh-oh. And this is data frame. And this data frame is, this data frame has 4 variables, 5 observations. It has time, ticker, price, and quantity. It is the ticker is a stock ticker. It's Microsoft, Google, and Apple. So the 3 companies' company stocks, transaction price, and the quantity of the transaction, and the time that each transaction takes place. And now we have another data called quotes. So this data is from the TAQ data sets, the trade and quotes. If you trade stocks, you know that you have quotes data. That means you have the buyers will give a bid price and the sellers will give an ask price. But these prices are not transaction prices. When they have when the bid price that the buyer raises matches the seller price, which is the ask price, then the transaction will happen. And that price in the transaction is the transaction price in the price column. And the quantity indicates that how many stocks are being transacted at this price. So usually you see a lot of quotes. Some people just say, hey, I want to buy the stock at this price. I want to buy the stocks at that price. But eventually nobody will sell them at that low price. And some people will say, hey, I want to sell this stock at that price. But eventually most of the quotes, I shouldn't say most of them, but for some stocks, most of them, for many of the stocks, many of the quotes are not being implemented. So they're not executed. They're just a bid and not the price. They are not the transaction price. So we have the quotes data. We have the trades data. We want to combine the 2 data sets together so that we can analyze, for example, how long you should wait before a bid price convert to a transaction. Okay, by quotes mean that you raise. You give an order. You just say, I want to sell, I want to buy. And if it matches with another order, then the two orders, the buy order and sell order, will become a transaction. So I want to merge the two data sets. Okay. So now I can use the merge as of. Look at this variable. This is function. So it merges trades and quotes. It's kind of like left and right on the variable called time and by ticker. So it only merges the observations with the same ticker but similar time. Here, the first observation of the merged data. How do we get this? See, now you have 6 variables: time ticker, price and quantity from the trades data, bid and ask variables from the quotes data. You have the Microsoft. So this data, trades data, it has 2 observations for Microsoft. For quotes data, it has 4 observations for Microsoft. And for this trades data is, the hour, minute, seconds are the same. So we look at the second, the milliseconds after the decimal. So 0, 2, 3. And it matches with the 0, 2, 3 here. So the bid and ask prices are being merged to here. Okay. For this Microsoft is 038, and we have the price and the quantity here, exactly the same. But we have a problem here. We do not have 038 in the quotes data. So what does it do? It automatically search the nearest observation before this time. So before 038, the nearest, the closest time is 030 Microsoft. So this bid and ask prices are being merged here. Be very careful that it is not the nearest one. It's the nearest time before the trace time. Okay, the nearest time is 041, which is not being merged into here because it happened after the trades, which makes sense because you first have quotes, then you will have trades. You can't have a future quotes to be transacted. You should first have some quotes, then after some time, these bid and ask orders will convert to a transaction. So you have a transaction price and quantity. Then let's look at Google, because we have 2 Microsoft. Then there is no other Microsoft observations in the trade data. So now we look at Google. Google, the time is 048. Do I have 048? Yes, we do. We have this. So it's merged here. And now it has a different price being transacted at the same time. Does it mean, how is it possible that you have 2 transaction prices at the same time? It's possible because probably it happened in 2 different stock exchanges. Or maybe it has some milliseconds, like nanoseconds, but the time value is not as accurate to that level. So 048 here, you also have this price, so this price is merged here, and you have 048 bid ask price here. For Apple, you have 048. And let's look at Apple. No, it doesn't have a time for Apple before 048. It does have one after 048, 049. But you can't have the bid and ask price before. I'm sorry, bid and ask price after the trade price, the transaction price. Therefore, this observation is not merged into the merger data. So you have NAM for bid and ask. Okay. There were some other parameters. For example, tolerance. The tolerance is 2 milliseconds. So that means if the quotes time happens 2 milliseconds before the trade time, it will not be recorded. They're almost the same except for this one, 038. So the nearest quotes time before the transaction time is 030, which is 8 milliseconds before the 038. So it's not recorded here. It's not merged here. And for this one, the tolerance is 10 milliseconds. If we have this, then I think the results should be the same as this one, because yeah, it's the same as this one. But if we have this one allow exact matches is false, then we will have many NANs. Because for the 023 here, no, here, it doesn't have a Microsoft bid and ask price before, not equal to, but before 023. So we have an NAN here. And similarly for Google, the two Google observations here, we do not have the quotes time before the trades. Okay, before the trades time. The idea is that the quotes time should always happen before, not at the same millisecond at the trades time. So as I said, it's almost impossible for you to have a bid and ask order and at the same time the orders are transacted. So you must have the bid and ask orders before the trades time. This is the idea. Okay. So this is the variable allow exact matches. And now you have another one called direction equals nearest. So what changes? Two things changes. One is that if you don't have this, this one, the direction equals the default one is backward. Okay, you look the time before the look at the quotes time before the trace time. You can also look at forward, the quotes time after the trace time, or the nearest. If you look at the nearest, if you use the nearest value for the direction parameter, there will be two changes. First is this. Okay. Remember that here, 038 time. The bid and ask prices, for bid and ask prices, we choose the 030 because the default direction value is backward. We look at the time, nearest time before 038. Now since we change it to nearest, we can look at both directions. So this one will be merged into the combined data, not the 51.97, but 51.99. Look at this, 99. Okay, when we have the direction equals nearest, we have the 51.99. If we don't have that, we will have 51.97. The other change is for this, the apple at 048. For the quotes data, the only observation for apple is 049. So when we don't specify the direction, the default value is backward. The quotes data doesn't have an apple observation before 048. Therefore, we have the end here. But since we specify the direction value as nearest, it can be this variable. This observation's beta not surprise can be merged into the new combined value. 97.99, 97.99. Okay. So this is a merge as of. So far, we have explained many very commonly used Pandas functions for data processing. We don't have time for all of them, but we will give you more examples or more videos in the future, if possible. But to finish all of them, I suggest you to just look at the documentation, because in the documentation, you will find that Pandas really have a lot of functions. It has 26 general functions, nearly 300 series functions, and nearly 200 data frame functions, and the 100 functions for panel, and group by, window, resampling, and in total about 1,000. Actually, this number is a bit outdated, probably over 1,000 now. For this master, for this module, our introduction of the Pandas functions is temporarily over. Okay, we will then talk about more things in the next videos.